Okay, so our meeting today, I will start to cover a new topic related to rainfall. But before doing this, I would like to solve this example. We need to determine time of concentration. Before starting time of concentration, I would like to remind you for something. If you have area of land and we have rainfall on this area, we have a point here, or we have a drop of water. This drop of water will take a path to be collected in a stream until a point of analysis. This time, the time needed for this drop of water to reach to the point of analysis, this is the longest time. What you mean by longest time? Any other drop of water will take shorter time to reach to this point. Any other drop of water will take shorter time to reach here. So if you are looking for time of concentration, TC, I will look for the longest time needed for any drop of water to reach to the point of analysis. In the way of this drop of water to reach to the point of analysis, probably we have three types of flow: T1 plus T2 plus T3. The first flow, probably for this area of land, called overland flow. Overland flow. Then probably the water will be more concentrated to create small rivers or small channels to be more concentration. This one called shallow concentrated flow. Then the last step is stream flow. You are in the stream right now. Each type of flow, the first one has time T1, the second one has time T2, the third one has time T3. If you add these times together, we will get the time of concentration. This time of concentration is very important. Next week, we will use it for design. This time of concentration is very important. Anyway, we need to determine the time of concentration in minute at watershed outlet point D. We have here outlet point D. We have paved watershed. The first flow or the first phase of flow. The length of this one is 1,000 feet. The first 300 feet is sheet flow and the slope equal 2%. The second step, water flow through open channel with length 500 feet. This open channel flow 500 feet with the velocity 3 feet per second. Then flow through pipe for 400 feet and the velocity is 2.5 feet per second. Let's start with the first flow. Sheet flow or overland flow. Type of surface, paved surface. The length equal 300 feet. Only 300 is sheet flow. The slope equal 2%. Do you remember last meeting? If we have overland flow, I'm going to use this chart. Let's try. Let's try. The length is 300. The length is 300. We are here. The type of surface is paved. We are here. From this point to this point, I will draw a line to intersect with the pivot line. The slope of this flow is 2%. So slope here is 2%. From this pivot point to 2%, I will draw another line and extend it to intersect with the the last scale. Probably your time here is 7 minutes and something, 7.1. So your first time T1 equals 7.1 minutes. It's very easy. Piece of cake. Just you need to figure out what is the length, what is the type of surface, draw a line from this pivot point and the slope. I will draw another line to figure out what is the time T1. If you have overland flow or sometimes called sheet flow. The second flow will be through open channel flow. The second one, we need to use this chart. Why? By slope and the type of surface to figure out the velocity. Once you get the velocity, I can get the time T2 by length divide velocity. I will not use all of this stuff. Do you know why? Because you are lucky. In this problem, velocity is given 3 feet per second. Length, excuse me, length equal 500 feet. Okay, I am good. You can go ahead and find T2 directly. We don't need to use any chart. So T2 equal length feet divide velocity feet per second. So the value will be 166.67 seconds. You can convert it to minute to 2.8 minutes. The third flow, which is stream flow. You need to figure out what is the velocity by Manning equation. Once you get the velocity and the length, I can figure out T3. I don't need to do this. Do you know why? Because velocity is given 2.5 feet per second. You are lucky. The length is given 400 feet. So I can figure out the time T3 equal length divide velocity. Your value will be 160 seconds, which is equivalent to 2.7 minutes. Once you are done with the first flow and the second flow and the third flow, I can figure out the time of concentration equal T1 plus T2 plus T3 equal 7.1 minute plus 2.8 minute plus 2.7 minute. So the time of concentration will be 12.6 minutes. That makes sense? Probably you can have a problem like your homework. We need to use this chart to figure out what is the velocity. We need to use this equation to figure out what is the velocity. Sometimes we have example like this one, velocity is given. Probably. Why not? That makes sense? Do you have any question for this example? If you have any question, please let me know. Okay, great. The next part in our meeting today, I am going to talk about rainfall. Just to remind you, our target in this part of the course, we have area of land and we have rainfall on this area, and we need to figure out what is the discharge Q coming from this area of land due to the rainfall. Because if you can figure out what is the Q that needed to be collected by this stream, we can design it. We can go back to the first part of the course and we can design the stream. So before starting to figure out what is the value of Q, we need to understand more information about rainfall. Do you think anybody in this world can expect the rainfall exactly 100% that will happen next week? Do you think we can expect what will happen tomorrow? I'm talking about rainfall, just to be clear. Do you think we can expect how much rainfall next spring 2022? Actually, in this winter, during February, Texas suffered from a snow storm. Do you remember that week? Nobody expected this bad weather in this year. So we don't know. If also we have something in the world right now called climate change. So we are talking about something called haphazard pattern. Rainfall occurs in haphazard patterns. We are expecting, but not 100%. Okay? So sometimes we are designing our sewer system to collect rainfall, but sometimes flooding will happen because we don't know. We cannot expect 100% for the future related to rainfall. So making it very difficult to quantify for design purposes. That makes sense? So keep in your mind, what we are trying to design, just assessment. Just we need to expect, because rainfall occurs in haphazard pattern, making it very difficult to quantify for design purpose. However, over the past 100 years, 100 years or 200 years, reams of data have been compiled on rainfall in the United States. So over 100 years or 200 years or hundreds of years, we have data that saying for example, every spring on commerce, for example, over the last 100 years, we expected heavy rainfall during March, will continue for 2 hours, and will be repeated every 5 years. Right now, we can say every February, for example, or every winter, Texas will be under the effect of snow, storm, and will be repeated every 50 years. Yeah, what happened last month in February, the people said this is not happened since 50 years ago. So we can expect after 50 years, we can expect the same snowstorm will hit Texas one more time. So our data based on statistical analysis, based on data collected over hundreds of years. This data will be used to quantify how much rainfall we are expecting. So statistical analysis of this information leads to the determination of an average or typical rainfall. Actually, we have atlas for United States. This atlas looks like this. I will show you something, but this atlas is related to snow, not to rainfall, but something like this. Just a second. Yeah, something like this. We have a map for United States. You need to locate your area of land or city or town or village. So for example, we are here in this area of Texas. Based on this atlas, I can figure out this number, but this map is talking about snow. So we expect 5 pound per square feet inch. I'm sorry, snow. 5 pound per square feet snow. The rainfall atlas looks like this. Based on the area, I can figure out how much rainfall are expected. That makes sense? So, Rainfall Frequency Atlas of the United States, it's a technical paper which shows through a series of maps the expected size of storms throughout the country. The report covers rainfall duration of 30 minutes to 24 hours and return period from 1 to 100 years. Before starting, we can continue, we can understand the rainfall duration. Yeah, we can understand this. Rainfall duration, yeah, we expect rainfall tomorrow will last for 1 hour or 2 hours. We understand the duration is the time or the period of the rainfall during the day. What is the meaning of return period? Return period means, for example, the snowstorm that hit Texas this year will be returned one more time after 50 years. So next year, we will not expect it. The year after, we will not. The year after and after, we will not. Because this snow will be repeated 50 years ago. I'm talking about, for example, I'm not talking about fact, but I'm talking about, for example. So We have something called return period or frequency. Okay, we have another technique, National Oceanic and Atmospheric Administration, NOAA. It's a follow-up study with prepared to depict more details precipitation data. We have a website here. This website, you can locate the city, and the website will tell you what is the rainfall expected. The size of a storm is described by number of inches. We have a rainfall tomorrow. So what do you think about this rainfall? Okay, you can tell me different story. How much inch or how many inches will be collected from this rainfall? If you are watching brief news or something, any broadcast expectation, you will see, hey, there is a snowstorm hit Colorado, and the snow expected is 2 feet snow. So what does it mean? The snow will be accumulated on the ground surface until reaching 2 feet depth or thickness. So we can express how much snow you expect by what is the depth of the snow layer. Also, for rainfall, we can express the size of the rainfall by how much inches will be collected from the rainfall. And also, what is the duration of the rainfall? 1 hour, 2 hours, 3 hours, or whatever. Rainfall frequency, or called return period, probability of occurrence, is described by the term return period, which is the average number of years between two rainfall events that equal or exceed a given number of inches over a given duration. The next term called, or diagram called, intensity duration frequency. Intensity duration frequency. For each city in United States, we have this chart. For each city. The relationship between rainfall intensity, rainfall intensity, which is called capital I, which is in term inch per hour. How many inches per hour do you expect from this rainfall? And duration of the rainfall. And the return period, every 25 years, this rainfall will be repeated. Every 50 years, this rainfall will be repeated. So these three terms together will create this chart. So the relationship between rainfall intensity and the duration for various return period for a given location in the United States is shown on the intensity duration frequency. So for Commerce, for Greenville, for Dallas, for Houston, for every single city in the United States, we can expect this chart for every city. For example, let's assume we have rainfall. The duration of this rainfall is 1 hour. So the duration is 60 minutes. And this rainfall will be repeated every 25 years. So I will go up until you hit the curve for 25 years. This one. 25 years. From this point, I will go horizontally here to figure out what is the value here. Will be intensity equals something like 2.4 inch per hour. What does it mean? This rainfall, which will last for 60 minutes and will be repeated on this city after every 25 years, will give you intensity equal to 2.4 inch per hour. What does it mean? Every hour, we can expect 2.4 inch of water. That makes sense? That makes sense? So the duration of the rainfall, the frequency of the rainfall, the location of the city, because every city has different chart. I can tell you what is the intensity. Intensity is a very important parameter. So right now, because this parameter will be used next week, right now we have time of concentration TC. We can figure it out. We have value called intensity of the rainfall. Intensity, we can figure it out. Intensity comes from different chart. Each city has special or specific chart based on the rainfall duration, based on the frequency every 5 year, 10 year, 25 year, 50 year, 100 year. I can tell you what is the intensity of this rainfall. The intensity is in inch per hour. How many inch you expect every 1 hour? Any question so far? Any question so far? So let's assume we have expectation for a rainfall tomorrow on commerce. So I will open the chart related to commerce based on the data given on this website or the Atlas for Dallas for commerce. I will determine the expectation for the rainfall duration. And what is the return period? This rainfall will be repeated every 5 years or every 1 year. That's fine. We have here 5 years. Sometimes we have 1 year based on the city. I will go up, then I will hit horizontally to figure out the intensity, because this intensity next week will be used to figure out what is the discharge from the rainfall. We have example here. In a rainfall event occurring in New Jersey, so this chart related to New Jersey, there is a rainfall over a duration of 20 minutes. The rainfall will last for 20 minutes only. The returning period for this rainfall will be repeated every 25 years. What is the rainfall intensity of this rainfall? Okay, I will open charts for New Jersey based on the duration, which is 20 minutes, and the returning period 25 years, which is this curve. So I will go up from here until I will hit the curve for 25 years. Then I will go horizontally to this scale to figure out the intensity of the rainfall equal 4.5 inch per hour. This rainfall will produce 4.5 inch per hour. Every 1 hour, we can expect 4.5 inch of water. That makes sense? That makes sense? So I'm trying to move slowly in this part. So one more time, we can right now calculate the time of concentration, and based on the city and the returning period, the duration of the rainfall, I can figure out the intensity of the rainfall. This intensity is inch per hour. Any question so far? Okay, looks good. We have another concept here called hydrograph. Hydrograph, we have two types of hydrograph. The first one, total hydrograph. The second one called unit hydrograph. Based on the data of the hydrograph, we can do some calculation to figure out the volume of water collected, or the depth of rainfall, or the area of land. We will cover all of these information next meeting. So next meeting, I will start with what is the meaning of hydrograph, what is the meaning of this curve or data on the curve, and we will go through the two examples because one of them will be in your next exam.